Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics, Topic 5, Probability Generating Functions. This lesson is on the sum of independent random variables. Let's look at probability distributions for two variables, x and y. X and the probability that x, the variable is x, a particular value for 1, 2, and 3. Those probabilities are 1 over 4, 1 over 4, 1 over 2. And the second variable, y, the probability that y, the variable, is y, a particular value for 2, 4, and 6, with probabilities of 1 over 3, 1 over 3, and 1 over 3. I will mark off on the side a section that isn't directly related to, it is related to the concept we're working with, but not the calculations that we'll actually be using. We want a more efficient method of doing a particular calculation than what I'm about to work through. But let's take the scenario in which we want to understand the probability that x plus y together equal 7. There are two ways that can happen. X is 1 and y is 6. If x equals 1, which has a probability of 1 over 4, and y equals 6, which has a probability of 1 over 3, we can multiply to get the combined probability, which is 1 over 12. Another way this could happen is if x is 3 and y is 4. Probability that x is 3 is 1 over 2. Probability y is 4 is 1 over 3. If we multiply these, we get 1 over 6. And then for the union, we would add 1 over 12 plus 1 over 6 to get to total probability of 1 over 4. That's the probability that the sum of x and y equals 7. And in working with probability generating functions, up at the top I'm going to give the rule that we'll be working with. The probability generating function for the sum of x and y equals the probability generating function for x times the probability generating function for y. I'll start with the individual probability generating functions. For x, I take the probability of the first scenario, which is 1 over 4, times t to the power of the x for that scenario, which is 1. Then next, 1 over 4 times t to the power of x is 2. And finally, 1 over half times t to the power of 3. And for y, similarly, the first scenario has a probability of 1 over 3, that y is 2, so t is to the power of 2, plus another 1 over 3 probability, t to the power of 4, plus 1 over 3, t to the power of 6. And now for the probability generating function for x plus y. Notice our rule is we multiply, so I will multiply the first term for the probability generating function of x, 1 over 4t, times 1 over 3t squared, as well as times 1 over 3t to the power of 4, as well as times 1 over 3t to the power of 6. Similarly for the second term, multiplying by all three terms in y. And then for the third term, the same will be happening. And after the multiplications with simplification, I get to 1 over 12 times t to the power of 3 times the quantity 1 plus t plus 3t squared plus t to the power of 3 plus 3t to the power of 4 plus t to the power of 5 plus 2t to the power of 6. This is the probability generating function for x plus y. Now let's look at a probability distribution for the sum of x and y. X plus y, and the probability that the variable x plus the variable y give the particular result of output x plus y. If we go back and look at our possible combinations, taking the x of 1, we could have 1 plus a y of 2, 1 plus a y of 4, 1 plus a y of 6, and similar combinations for x equals 2 and x equals 3. And those result in the possibilities of 3 through 9, 3, 4, 5, 6, 7, 8, 9. And using the probability generating function, rather than trying to work through these individual calculations by combining the original probability distributions, as I did over on the right side of this first screen, using the probability generating function down at the bottom that we've created, what we find is the following probabilities, as I show here. And if I add these probabilities, they, as they should, produce a total of 1. Now let's look at expectation and variance for the combined probabilities. And first I'm going to note from previous calculations individual expectation and variance, and then we'll reference back to these in a moment. Expectation of x is 9 over 4. Variance of x is 11 over 16. Expectation of y is 4. And variance of y is 8 over 3. Recall from previous topic content that we need the first and second derivatives of the probability generating function to find expectation and variance. So I'm going to post the probability generating function we've created, and I want to find the first derivative for the probability generating function with an input of 1, as well as the second derivative with an input of 1. And to make the process easier, I'm going to undistribute this t cubed out front in my probability generating function. If I bring that inside of the brackets, we end up with the first term is t to the power of 3, next term t to the power of 4, then 3 times t to the power of 5, t to the power of 6, 3 times t to the power of 7, t to the power of 8, and 2 times t to the power of 9. So now the first derivative, I have 1 over 12 times 3. For a moment I'm going to leave the t out. 3 times t squared plus 4 times t cubed plus 15 times t to the power of 4 plus 6 times t to the power of 5 plus 21t to the power of 6 plus 8t to the power of 7 plus 18t to the power of 8. And here I will replace those t's with my input of 1. So 3 times 1 squared, 4 times 1 cubed, 15 times 1 to the power of 4, etc., which simplifies to 25 over 4. And then for the second derivative, starting with the first derivative, I have 1 over 12 times now 6t to the power of 1 plus 12t to the power of 2 plus 60t to the power of 3 plus 30t to the power of 4 plus 126t to the power of 5 plus 56t to the power of 6 plus 144t to the power of 7. And again, I'm replacing t with an input of 1. So I end up with wherever I had a t, the multiplication by 1 to the appropriate power, with a result of 217 over 6. And now I can arrive at my first expectation for x plus y from a prior lesson. Recall this is the first derivative of the probability generating function with an input of 1, which we've calculated as 25 over 4. And for the variance of variables x and y summed, we want the second derivative with an input of 1, 217 over 6, plus the first derivative with an input of 1, 25 over 4, minus the square of the first derivative with an input of 1, so minus 25 over 4 squared, which results in 161 over 48. And as confirmation, if we go back up to the individual expectation and variance that I posted, the expectations of 9 over 4 and 4, when summed, give 25 over 4. And notice that's the expectation we've calculated at the bottom. And similarly, if we take the individual variances, 11 over 16 plus 8 over 3, summed, we get 161 over 48, same as the calculated variance at the bottom. And here, for ease of reference, I'll post here the formulae from the MF19. And now here down at the bottom right, you can see the formulae for expectation of variance. These are the formulae I used to get the expectation and variance individually that I posted in summary form at the top of the screen, as well as the formulae we used for the expectation and variance of the combined variables at the bottom. And this completes the lesson on probability generating functions, sum of independent random variables.